Hi guys, welcome back to my video about programming with Golang. This video is part 2 of topic number 4, concurrency. So in this video, we will discuss how Golang supports the message passing style of concurrent programming. In particular, we will learn about channels in Golang. First of all, let's review what we have learned in the first lecture of concurrency. In that lecture, we have learned that Go supports two styles of concurrent programming. The first style is message passing, and the second style is shared memory. This lecture will explain how Go supports the message passing style. Recall that in the message passing style of concurrent programming, concurrent activities interact by sending messages to each other via communication channels. There's no shared variables among concurrent activities. In the first lecture, we also learned that concurrent activities in Go are Go routines. Every program has the main Go routine when the program starts. New Go routines are created by Go statements, which are regular function or method calls, but prefixed with the keyword Go, as in this example. The function or method call in the Go statement then will be executed in the newly created Go routine. If Go routines are activities of a concurrent Go program, channels are the connection between them. A channel is a communication mechanism that lets one Go routine send values to another Go routine. Having channels is how Go supports the message passing style of concurrent programming. Each channel is a conduit for values of a particular type. In Go syntax, the type of a channel whose elements have time int is written chan int. In general, a channel type starts with the keyword chan followed by an element type. To create a channel, we can use the built-in make function, which is the same one that is used to create a map. But here, the argument of the make function must be a channel type, such as chan int, instead of a map type. This make function allocates memory for a channel and returns it. You can then assign the created channel to a variable ch. Like maps, a channel is a reference to the data structure created by the function make. So here, ch is actually a reference to a channel. Two channels of the same type may be compared using the equality operator. The result of the equality comparison is true if both are references to the same channel data structure. A channel may also be compared to nil. A channel has two principal operations, send and receive. Both operations are written using the left arrow operator, which is denoted by a less than sign followed by a minus sign. The data flows in the direction of the arrow. So in a send operation, the left-hand side of the arrow is a channel and the right-hand side is a value to be sent. For example, the statement ch left arrow v is the operation that sends value v to channel ch. A receive operation is an expression started with the left arrow followed by a channel. It returns the value received from the given channel. That value can then be assigned to another variable in an assignment statement. For example, the statement v colon equal left arrow ch assigns the value received from channel ch to variable v. It also, it also declares variable v because it's using the colon equal operator. If you write the received expression alone like this, the value received is discarded. By default, sends and receives block until the other side is ready. This allows Go routines to synchronize without explicit locks or condition variables. Here, an operation blocks means its Go routine stops and waits. To close a channel, we call the built-in close function, passing a channel as the argument. The call close of ch will close the channel ch. Close indicates that no more values will be sent on this channel. Also, sending on a closed channel will cause a panic runtime error. And note that only the sender Go routine should close a channel, never the receiver. This is a Go program that shows an example of channels. This program has a function sum that takes two arguments. The first argument s is a slice of integers, and the second argument c is a channel of integers. Function sum computes the sum of all elements in the given slice S and send the result to the given channel C. In the main function, we create a slice S of integers and we want to compute the sum of the numbers in slice S. But instead of calling function sum with the entire slice S as argument, the main function calls function sum twice, passing each half of the slice S to each call. Both calls to function sum share the same channel C, which is created by the make function. So the sum of each half of slice S will be sent to the channel C. Each of the calls to function sum is placed in a Go statement. So it distributes the work between the two Go routines. Once both Go routines have completed their computation, it calculates the final result by receiving two values from channel C and calculating the sum of those two values. So, how many Go routines does this program have? This program has 3 Go routines connected by one channel C. The main Go routine is the receiver, and the other new Go routines are the sender. Note that here there's no guarantee that variable x will receive the value from the first call to function sum, and y will receive the value from the second call to function sum, because we don't know which Go routine will execute and complete first. A channel created with a simple call to function make, as in the previous example, is unbuffered, which means the channel does not store any values. But in Go, A channel can have a positive capacity or length to store values, in which case the channel is called a buffered channel. To create a buffer channel, you just provide a positive capacity of the channel as in as the second argument to function make. For example, if you pass number 9 as the second argument to function make as in this example, then it creates a buffered channel with capacity 9. If you pass 0 or omit the second argument to function make, then it creates an unbuffered channel. If CH is a channel, then function cap of CH returns the capacity of a channel CH. Recall that by default, the send and receive operation on channels blocked until one side is ready. Therefore, sends to a buffered channel block only when the buffer is full, because then the channel is not ready to receive values sent, and receives from a buffered channel blocked when the buffer is empty. Here is an example demonstrating how buffered channels work. In the main function on the left, we create a channel CH of integers with capacity 2. So CH is a buffered channel. Then we make two sends to channel CH. The first one sends number 1 to CH, and the second one sends number 2 to channel CH. Finally, we make two receives from channel CH and print out the result. The first receive returns number 1, and the second receive returns number 2. This means that the buffer of a channel is a queue, which operates in the first in, first out basic. In the main function on the right, we also create a channel CH with capacity 2 and make two sends to channel CH as in the main function on the left. But then instead of receives from CH, we make another send to CH, trying to overfill the buffer of the channel. This leads to a fatal error with the error message on go routines or on sleeps deadlock. Here is another example which demonstrates a difference between buffered channels and unbuffered channels. In this example, we have two simple programs in which we create a channel CH and then send number 1 to CH. The only difference is that in one program, CH is a buffered channel with capacity 2, and in the other program, CH is an unbuffered channel. Note that in both programs, there's only one go routine, which is the main go routine. So when the main go routine sends on the unbuffered channel, there's no other go routine. This leads to a fatal error because a send on an unbuffered channel only works when there is another go routine ready to receive it. But a send on a buffered channel always works as long as the buffer is not full. Therefore, the program with the buffered channels works fine, no error occurs, because when the send to channel CH is executed, the channel buffer can store two values. The key difference between buffered channels and unbuffered channels is that unbuffered channels are synchronous while buffered channels are not. Communication over an unbuffered channel causes sending and receiving go routines to synchronize. In particular, a send operation on an unbuffered channel blocks the sending go routine until another go routine executes a responding receive on the same uh, channel, at which point the value is transmitted and both go routines may continue. Conversely, if the receive operation was attempted first, uh, then the receiving go routine is blocked until another go routine performs a send on the same channel. When a value is sent on an unbuffered channel, the receipt of the value happens before the reawakening of the sending go routine. This means that the value must be received before the sending go routine is unblocked. To illustrate the synchronization of unbuffered channels, let's consider two versions of function main in this example. In both versions, the main function starts with creating an unbuffered channel, CH, and then in the first version, it calls function receive of CH in a go statement, followed by sending number 1 to channel CH. In the second version, the order of the go statement and the send operation is reversed. Here, function receive takes a channel of integers as the only argument and makes a receive from the given channel and prints out the result. So the function call receive of CH will execute a receive on the channel CH. The first version works because when the send statement is made by the main go routine on the unbuffered channel CH, there has been another go routine that is executing a responding receive on the same channel CH. The second version doesn't work because when the send statement is made by the main go routine, there's no other active go routine because at this point the go statement has not been executed. Note that the function call receive of CH in this example is equivalent to the calling function fempty.println of arrow CH. So because both just make a receive from the channel CH and print out the value. However, if you replace the function call as receive of CH with fmt.println of receive from CH, as in the second version of function main here, it still doesn't work because when the receive from CH is performed by the main go routine, there's no other active go routine. To understand this, recall that arguments of a function call in a go statement are evaluated in the current go routine before the new Go routine is created. So in this second version of function main, the argument of the println function, which is the receive operation, is evaluated by the main Go routine, at which point a new Go routine has not been created. So for sending and receiving on unbuffered channels to work, we need to make sure that there are synchronizing Go routines on the same channel. So let's stop here for now, and thank you for watching. I hope to see you again in the next video, where we will show you more practical examples of concurrent program in Go, and we will discuss more about channels and Go routines in Golang.